Let's find the inverse of the function f of x equals 3x. To find the inverse function, we'll follow a step-by-step process. Step 1. Replace f of x with y. This gives us y equals 3x. This helps us treat the function as an equation between two variables. Step 2. Solve for x. To isolate x, we divide both sides by 3, giving us x equals y over 3. Step 3. Replace x with y and y with x to get the inverse function. This gives us y equals x over 3, which we can write as f inverse of x equals x over 3. Now, let's verify this is correct using the inverse function property. This states that f of f inverse of x equals x, and f inverse of f of x equals x. Let's check both. Let's check f of f inverse of x first. We start with f inverse of x, which is x over 3. Then we apply f, which means multiply by 3. 3 times x over 3 equals x, verifying the first property. Now let's check f inverse of f of x. We start with f of x, which is 3x. Then we apply f inverse, which means divide by 3. X over 1 equals x, verifying the second property. Let's visualize these functions on a coordinate plane. Here's f of x equals 3x in blue, and its inverse, f inverse of x equals x over 3 in red. Notice how they're reflections of each other across the line y equals x, which is shown in green. This reflection property is true for all function inverse pairs. In conclusion, we found that the inverse of f of x equals 3x is f inverse of x equals x over 3. We verified this using the inverse function property and saw how the graphs of a function and its inverse are reflections of each other across the line y equals x.